Hello everyone, in this video I am going to talk about the importance of accessibility in designing digital AI products. As a UX designer, if we don't consider accessibility, we may fail to build truly inclusive products that works well for everyone. So please watch the video till the end to learn how to design more accessible products. Before we begin, let me introduce myself. I am Pavani Priya Saja, a UX designer, mentor and speaker. Through this channel, I share my knowledge and help UX designer build new skills and learn what's important when designing AI products. Now, let's jump into the video. Imagine you are designing an AI tool. If someone can't access it or doesn't understand how to use it, the product won't succeed, right? That's where the accessibility comes in. Accessibility in UX means designing products so the people of all the abilities can see, understand, navigate and use them easily. If ensures we don't exclude anyone due to permanent, temporary or situational limitations. Accessibility is not just for a few people, it benefits everyone. When a product is easy to access and use, it creates a better experience for all users. This is especially important for AI products. AI has the power to remove barriers at scale, but if accessibility is ignored, it can also increase exclusion and bias. That's why accessibility should be a core part of AI product design. What accessibility in UX means? Accessibility in UX means designing digital products so people with different abilities can use them easily. This includes people with a visual, hearing, motor, cognitive or speech impairments. Accessibility is not a nice to have a feature, it's a basic requirement for good design. In practice, accessibility includes things like easy to read text, good color contrast, keyboard-friendly navigation, support for screen readers, clear layouts and structure, text alternatives for audio, video and complex interactions. People also use a wide variety of devices every day, such as mobile, tablets, laptop and assistive devices. That's why products and services should work smoothly across different screen sizes and devices. So, users can access and use them easily no matter what device they are using. Today, accessibility is a part of inclusive design. When we designing for people with disabilities, we also improve the experience for everyone, especially users in noisy places, low internet areas, on small screens or in high distraction situations. Why does accessibility matter for AI products? AI products are increasingly used to access information, service and make decisions. If these systems are not accessible, many users can be completely left out of important opportunities. AI also has the power to greatly improve accessibility. For example, through automatic images, description, smart screen readers, voice-based interactions, and adaptive user interfaces. However, this only works when teams intentionally design, test, and build AI products with inclusive users in mind. Many AI accessibility features rely on sensitive data such as voice recordings, biometric data, or health-related information. Because of this, it's important to combine accessible design with strong privacy, transparency, and user control to ensure users feel safe and protected. Accessibility issues in AI products often happen because teams don't think about how AI generated content changes dynamically and how it works with assistive technologies. As a result, many users face barriers when trying to use these products. Some common accessibility problems in AI product design. Color and contrast issues. AI tools often generate interfaces with low color contrast or rely too much on color to show information. This makes it hard for users with low vision or color blindness to understand the content. Low contrast color palettes fail accessibility standards. Important information is shown using color only, without labels or patterns. AI generated visuals may look good but don't work well with screen readers or high contrast models. Missing alt text. AI generated images, charts, and diagrams often don't have a proper alt text, or the descriptions are too generic to be useful, such as screen readers may skip images with a missing or poor alt text. Auto-generated descriptions can be inaccurate or confusing. Frequently changing AI content may not announce updates properly to screen reader users. Keyboard and focus problems. Many AI interfaces don't work well for users who rely on keyboards, such as keyboard focuses get stuck in chat windows or pop-ups. Custom AI interactions don't have keyboard alternatives. Focus indicators disappear when AI content refreshes and confusing users. AI-specific content challenges. Some AI features create new accessibility barriers instead of removing them. AI overlays or autofix tools can break screen readers. Long AI responses can overwhelm users with cognitive disabilities. Voice only or gestures only AI controls excludes users who need keyboard or screen reader options. Data visualization and mobile issues. AI dashboards and mobile apps often overlook accessibility basics, such as charts rely only on color and visuals without a table or text explanations. Touch targets are too small on mobile devices. Forms are missing labels or don't clearly announce errors. Next, simple way to reduce these issues. Teams can improve accessibility by taking small but important steps. Designing AI outputs using accessibility standards from the start. Text with a real assistive looks like screen readers and keyboards. Offer multiple ways to access information such as text, audio, and tables. Let users control content length and complexity. How AI changes the accessibility conversations. AI changes accessibility by adding scale, consistency, and real-time adoption. For example, AI can generate image description for thousands of images, adjust layouts based on user behavior, and instantly change language or reading levels too much user needs. At the same time, AI can also introduce bias if it is trained on non-inclusive data or designed without accessibility in mind. This can lead to problems like a poor recognition of assistive speech, difficulty with non-standard input devices, or exclusion of certain user groups. That's why accessibility must be considered across data, models, and UX design, not just the interface. When UX designers treat accessibility as a core skill, they are better prepared to design AI products that are not only innovative but also inclusive. This helps align powerful AI technology with ethical responsibility and real human needs. Why should you learn accessibility early? Learning accessibility early makes your work better, faster, and more impactful. Designing with accessibility from the first sketch is much easier and cheaper than fixing problems later, especially in complex AI systems with models and data flows. Accessibility leads to better UX for everyone. Designing for keyboard use, low vision, or cognitive load often results in simple, clearer, and more usable products. Many laws and standards like WCAG now require digital products to be accessible. These skills help reduce legal risk and build user trust and brand credibility. How to introduce accessibility in early design process. Bringing accessibility into the design process from start, often called shifting left, helps create inclusive products and avoids costly fixes later. First, pre-design preparation. Before you start designing, learn basic accessibility standards like WCAG level AA. Understand user needs across visual, hearing, and cognitive abilities. Plan time and budget for accessibility testing. Make sure the team has a basic accessibility training. This helps prevent accessibility issues before they appear. Accessibility during the design phase. So while designing, keep layouts simple and easy to understand. Avoid small touch targets and complex interactions. Use readable text, strong color contrast, and clear typography. Make sure designs can be used with keyboards. Plan headings, focus order, and structure clearly so developers can follow it. You can also preview designs using screen readers or accessibility tools early on. Testing and collaboration. Accessibility should be tested during design, not at the end. Testing prototypes with keyboards and screen readers early. Work closely with the developers, QA, and stakeholders. Fix high impact issues first, like a contrast, labels, and alt text. This saves time and improves the overall user experience. How to integrate accessibility testing into design workflows. Accessibility should be a part of every design works, not a final checklist item. Workflow planning. During ideation, review basic accessibility principles. During wireframes, check contrast, layout, and keyboard flow. During prototyping, run quick accessibility checks. Assign clear ownership. Designers handle visuals, developers handle code structure. Tools to support accessibility. Use design plugins like Stark or Contrast Grid in Figma. Use tools like Axe or Wave during handoff and development. Test focus order labels and interactions in realistic prototypes. Team collaboration. Do accessibility checks during design reviews. Run regular cross-team walkthroughs. Track accessibility issues in shared tools like Jira. Train teams with a short role-specific learning sessions. Continuous improvement. Use automated checks to prevent issues from coming back. Test with users with disabilities when possible. Review and improve accessibility regularly as the product evolves. Accessibility testing checklist for UX designers. UX designers can use this simple checklist when reviewing wireframes and prototypes. Can users see and hear it? Text contrasts meets accessibility standards. Content does not rely on color alone. Image have a planned alt text. Content works at 200% zoom without breaking. Can user interact with it? Everything work with a keyboard. Focus states are visible and logical. Touch targets are large enough. Forms have clear labels and error messages. Understanding. Can user understand it? Clear headings and structure. Simple language and constant navigation. Required fields are clearly marked. Feedback is shown after actions. Does it work across tools and devices? Okay. Logical readings, order for screen readers, responsive across screen sizes and orientations, works with the mouse, keyboard, touch, and assistive tech. These are the list of accessibility testing tools for UX designer. Accessibility testing tool help UX designer find and fix issues early. Directly inside design tools like Figma, Sketch and Adobe XD, these tools check things like color contrast, keyboard focus and missing labels, helping designs meet WCAG standards. If you had like me to show how to use these plugins in Figma or explain accessibility testing in your real world workflows, please comment below. I'll create a future video on it. Step-by-step accessibility audit for UX design. An accessibility audit helps UX teams evaluate prototypes, websites, or apps using WCAG 2.2 standards. Focus on the core principles: perceivable, operable, understandable, and robust. Step 1. Preparation. Define the scope, key pages, screens, or prototypes. Set the target WCAG level, usually AA. Gather tools, AIUX, DevTools, Lighthouse, NVDA/VoiceOver browser DevTools. Prepare a checklist covering color contrast, keyboard navigation, alt text for images from labels and error messages, semantic structures like headings or landmarks. Step 2. Automated scanning. Run tools like AIUX, Lighthouse or Wave on prototypes or live sites. Detect common issues, which is low contrast, less than 4.5:1, missing labels or alt text and empty links. Export reports and prioritize WCAG level A/AAA issues. Step 3. Manual keyboard testing. Navigate the product using only Tab, Shift plus Tab, Enter and arrow keys and check for logical focus order, visual focus indications or indicators, skip links or no keyboard traps. So test at 200% zoom and with reduced motion settings. Step 4. Screen reader audit. Use NVDA Windows or Voice over Mac on live prototypes. Verify logical reading order, proper headings, which is H1 to H6 and area landmarks. Descriptive alt text for images. Dynamic content announcements such as error messages in live regions. Step 5. Visual and cognitive checks. Use plugins like Stark or Colorblind to simulate impairments. Check for the color reliance and contrast. Minimum touch target size, which is 44 by 44 pixels. Fonts, clear labels and accessible error messages. Use of plain simple language for instructions and content. Step 6. Prioritize and report. Categorize issues by impact: critical keyboard navigation broken, high screen reader fails, and medium contrast or visual issues. Create a remediation plan with assigned team members, timeline for fixes, reset verifications. Share a summary of findings and progress with the team. This structured approach ensures your UX designs are inclusive, compliant, and user-friendly from prototype to production. Now, how to conduct accessibility testing while doing the vibe coding. When you are vibe coding and testing ideas quickly while designing, you should test accessibility as you code, not after everything is built. This helps catch accessibility issues early and avoid big fixes later. Automated accessibility testing during the coding. Use tools that automatically check accessibility issues while you code. Add accessibility liners to your editor to flag problems like missing labels, poor contrast, or incorrect headings. Run automated tools during commits or builds so accessibility issues are caught before code is merged. Use before extensions to quickly test accessibility on live prototypes while coding. These tools help you spot common WCAG issues early and save time. Manual accessibility testing in code. Automated tools help, but manual testing is essential. Test using only a keyboard to make sure users can navigate easily and see focus clearly. Zoom the page to 200% and enable reduced motion to check usability. Use screen readers like a VoiceOver on Mac or NVDA on Windows to confirm correct reading order and meaningful labels. Use browser tools to simulate color blindness or other visual limitations. Simple iterative workflow. Follow this repeatable flow while coding. Build a component, run automated accessibility checks, fix the issue, test with a keyboard and screen readers, commit the code. For reusable components, test them in isolation using tools like a component libraries or story-based previews. Fourth, track and improve continuously. Track accessibility issues just like any other bug. Fix high impact issues first, WCAG level A and AAA. Retest after fixes to ensure nothing broke. So here is my pro tip. Combining automated checks with a manual testing during vibe coding gives you a strong accessibility coverage and keeps your workflows fast, inclusive and aligned with your design process. For detailed guidance on building and testing accessible products, you can visit the WCAG official website and the link is provided in the description. In daily work, I use AI tools a lot and sometimes it can be overwhelming to process all the content they generate. This makes me realize how important good user experience is to use AI tools effectively. I strongly believe that accessibility in designing digital AI products is essential. As people increasingly shift from traditional search browser to AI chatbots, it's crucial to make AI products accessible for everyone. That's why learning accessibility in UX is so important for every designer. Understanding it helps us create inclusive, user-friendly and responsible AI products. If you would like me to create a video on how to conduct accessibility testing, drop a comment below. I'll create it and share it with you soon. And if you found this video helpful for designing accessible AI products, don't forget to like, share and subscribe. This way you won't miss any future videos and we can keep learning together. Thanks for watching. I'll see you in the next video.